Hi Math 30s. This video is going to be on radical functions. It's lesson 1 in your workbook on page 441. So a radical function, it's a function which contains a radical. And the simplest radical function that we could explore is the function y is equal to the square root of x. So if we were to graph and analyze y is equal to the square root of x, we could do that by completing this table of values. So if x is -4, if I take x out and input -4 and I try to take the square root of a negative number, I cannot do that. It's not going to be defined. Same with -1. We cannot take the square root of -1. That is not defined. The square root of 0, though, is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And square root of 16 is 4. So if I was to plot these points, 0, 0, 1, 1, when x is 4, y is 2. When x is 9, y is 3. And when x is 16, y is 4. Connect these points with a smooth curve. And what you would have is the graph of y is equal to the square root of x. It says for B, explain why the domain of this function is not the set of real numbers. Why is this graph, the domain, not going to be XER? And it has to do with the radicand. Remember that take the square root of a negative number, so x must always be greater than or equal to 0. Okay? So the square root of a negative number is not defined, essentially. State the domain of the function that I just graphed. So in set builder notation, the domain of the radical function is x is such that x must be greater than or equal to 0, x belongs to the element of the reals. The range of the radical function from looking at the graph would be y is such that y is greater than or equal to 0, comma yer. If you flip the page, what we're going to be doing now is transforming the graph of y is equal to f of x. And remember, when we undergo transformations, we must always follow stretches first, then reflections, then translations. Okay, if the original function is y is equal to the square root of x, and the new transform function is this here, what's happening to the graph? So there's going to be a y replacement. Y comes out and y minus 4 goes in. Remember, that is your k value, and k would be equal to 4. And what that would be a vertical translation 4 units up. So this graph is going to be translated vertically 4 units up. Okay, there's also an x replacement. So within the graph, x comes out and x plus 2 goes in. So x is replaced with x plus 2. That is going to be your parameter h, and h is going to be equal to -2. That was a horizontal translation, 2 units left. So if I take my graph now and I move it 2 units left, I will have my transformed graph, which would be there. And this is going to be at -2. We could get the domain and range from looking at this graph. However, what I always like to do for domain is you take the radicand, which is x plus 2, and that radicand must always be greater than or equal to 0. If you solve for x, you're going to have x is greater than or equal to -2, and that will be the domain of your function, and that is the domain of this function here. X is greater than or equal to -2. The range of this function is just from looking at the graph, and the range of this function would be y is greater than or equal to 4. Let's look at graph B. And again, we're having 2 transformations happening. We're going to have a stretch and we're going to have a reflection. So let's deal with the stretch first. So remember that the original graph is going to be y is equal to the square root of x. Y comes out and 2y goes in. If I said what is the parameter The easiest way to get the parameter, it's going to be the a parameter, but how you get that, if we were to isolate the y, so divide that by 2 and divide this by 2, a transformed equation becomes y is equal to 1/2 square root of negative x. So it is an a parameter, and a is going to be 1/2. The a parameter is a vertical stretch factor of 1/2. So this graph here, instead of stretching it up, it's going to be stretched or compressed down half the size. So the new graph would look like that after the stretch. Then we have a reflection happening. So the reflection is an x replacement, so x comes out and negative x goes in. That is going to be a horizontal reflection. And remember, with a horizontal or any reflection, you have to say the axes in which you cross. So horizontal reflection, it's a reflection in the y-axis. So essentially what happens is this graph here that's been vertically stretched by a factor of 1/2 is now going to come in, be reflected in the y-axis. So that would be your transform graph. It's been vertically stretched and then it's been reflected in the y-axis. C. We've got a couple of different things happening. I'm going to start with the reflection. So the reflection here, remember that this is going to be a vertical reflection, and that's our a value. So our a value is going to be equal to -1. Okay, the replacement though, it was a y replacement. Y is replaced with -y. That is a vertical reflection, and vertical is going to be about the x-axis. So the original graph, if I reflected about the x-axis, that's what the new graph would look like. And then we have a y replacement. So if the original graph is y is equal to the square root of x, it's y comes out and y plus 5 goes in. That, remember, is a k parameter. K would be equal to -5. And what's happening there is that it's going to be a vertical translation 5 units down. So where my graph currently is, it's going to move down 5 units. And that would be the transformed graph after the two transformations of the reflection and the vertical translation. You need to be able to list again the domain and range of this graph. The domain, if you look at the radicand, it's just x. Set the radicand greater than or equal to 0 and solve for x. That will give you the domain. So the domain of that blue graph is x is greater than or equal to 0. The range from these transform graphs you get from looking at the transform graph, putting it in your calculator in y1 and getting what it would look like. This is what the image would be though. And the range of that is going to be y is less than or equal to -5. That would be the range of the new transformed function. Okay, for D, a few things we have to do. Remember that this is going to be your b value, but your b value must always be factored out, and the b value hasn't been factored out here. I would have to factor out that 2. If I factor out the 2, what I would get would be my b value of 2, and then I would have x minus 1/2. That would be my new transformed equation. So what the transformations were that happened is, I'll start with the y replacement. So if the original graph is y is equal to the square root of x, in order to get that 3 on the right-hand side, the y will lie, so y is replaced with 1/3 y. Okay, so again, if I took that y out and I put in a third here, to get that 3 over as the a value, I'm going to multiply this by 3 and this by 3. So that is a y replacement. The a value is equal to 3. That is a vertical stretch factor of 3. The second transformation is I will do the second stretch, which is going to be the b value. So right here, that is going to be an x replacement. X is replaced with 2x. So it actually shows it better up here. X is replaced with 2x, and we know that that is going to be a horizontal stretch. So my b value is 2. So the stretch factor is equal to 1/2. So it's a horizontal stretch factor of 1/2. And then the last thing that's happening is within the function, so that's my h parameter, x comes out and x minus 1/2 goes in. That's going to be my h parameter. H is going to be 1/2, and that's a horizontal translation at 0.5 units right. Okay, so we've got two different stretches happening, and then we've got, it's moving 0.5 units to the right. If you were to graph this, what the new graph would look like, this would be 0.5 because it's going to go 0.5 units to the right. And after the two stretches, the graph would look something like this. So you then have to answer what's the domain and range of that graph. Again, domain. Set that radicand greater than or equal to 0 and solve for x. So x would be greater than or equal to 1/2. That is the domain of the function, right? The domain is x is greater than or equal to 1/2. The range of this function is y is greater than or equal to 0. The last class example says determine the domain and range of the function of, and it's telling us basically it's going to give us a vertical stretch and a horizontal stretch, okay? And it's going to give us different situations. So a is greater than 0, b is greater than 0. So what I do is I say, okay, pick values. If a is greater than 0, pick the number 1. So if this is a 1. If b is greater than 0, again, pick the number 1. What that would be y is equal to the square root of x. You know that y is equal to the square root of x. That's your basic radical function, and that would look like this. It wants you to say what the domain and range of that function would be. So the domain of the function is going to be x is greater than or equal to 0, and the range of the function is y is greater than or equal to 0. Let's do the same for b. If a is less than 0, I'm now going to pick -1. So I'll put a negative there. If b is greater than 0, I'm going to keep that at 1. So that would be the graph of y is equal to negative square root of x. You know that the negative in front of your function is the a value, which is a vertical stretch, but that's also a vertical reflection, right? And a vertical reflection is your reflection in the x-axis. So what this graph would look like was, here's your original. If that is reflected in the x-axis, this would be your new graph. And I would just erase the original because it just wants what the new graph would be. Okay, let's do the same thing. A is greater than 0. Let's choose that to be 1. B is less than 0, -1. So that would be the graph of y is equal to square root of -x. So the opposite is happening from b, and this is going to be, if it's inside the function, that is going to be a horizontal reflection. Remember that a horizontal reflection is a reflection about the y-axis. So let's draw the graph of y is equal to the square root of x, which would be that. And if you now reflect that in the y-axis, the new graph would be as follows. And that would be your new graph. And actually what it wants for this question is it is actually asking for the domain and range of the graph that would follow these parameters. So this one, the domain would be x is less than or equal to 0, and range y is greater than or equal to 0. Up here, we didn't do b, so domain is x is greater than or equal to 0, and range is y is less than or equal to 0. For this last one, if they want a to be a number less than 0, so let's pick -1, b to be less than 0, let's pick -1, that would give you this graph here, negative square root of -x. You have two reflections happening here. You are going to have a vertical reflection and you're going to have a horizontal reflection. So what happens when you have two reflections that occur? It doesn't matter which reflection you start with. So if this is the original graph, you could start with the vertical first or the horizontal first. So let's say I was to start with the horizontal, you'd go here. And then if I was to do the vertical next, remember vertical is now the up down, you would end here. This would be my end um, after the two reflections. I would end right here in quadrant 3. Watch how I could do it the opposite. We start here. Let's say I did the vertical first. So the vertical would take me down into the 4th quadrant. So that would go here. And then from here, if I horizontally reflect it, I get back to quadrant 3. So after the two reflections, where your graph ends up is where that red line is in quadrant 3. That would be your graph after two reflections. Doing the domain and range of that graph, we could see that the domain of the graph is x is less than or equal to 0, and the range of this graph is y is less than or equal to 0. Here are your homework questions that I want you to do. All of number 1, 2A, B, C, 3, 4, and 5. For those of you that watch podcasts, you'd be watching these 3 lessons here. And I'll just set up 2C for you. Okay, so for 2C, remember that your original equation is going to be y is equal to the square root of x. If we were to write the transformed equation, you know that we need to get rid of this 1/3. So you multiply um, by 3. You have to, that's going to become the a value. So the a value always goes in front of your function. So I'm going to need the 3 to be in front of my function. This is going to be my function, and I'm going to put, the 3 has to go in front of that function. So I multiply this side by 3, and that will cancel, and I multiply this side by 3. What I would be left with is I'd be left with y is equal to, if I expand this, it would be 3 square root of x minus 1, and then that is going to be minus 3. So now, when you're doing your replacements, it's going to be different than it originally looked. So, for example, if I was to take care of this k value, the k value is -3. And that replacement would be a y replacement. Y is replaced with y plus 3. Right? So that's what the replacement would be there. The x replacement, this x is replaced with x minus 1. That is an h parameter. H is equal to 1, and that's going to horizontally be translated 1 unit to the right. And then the 3 is going to be my a, right? So if my a is 3, vertical stretch is 3, that's a y replacement. Y is replaced with 1/3 y. And then what I would recommend is when you're graphing it, you could graph this new transformed function.